Let's go back one. There we are. Okay, so this first one, exponential rules. What do we do when we multiply powers at the same base? We add exponents, right? Okay, so x to the fourth and x to the fourth make x to the 8th. Y to the negative 3 plus y to the negative 1, or times y to the negative 1, negative 4. Okay, and then that's still squared over 2x y to the 4th. Now I need to make sure that everybody on the block gets a paper, so this got to get distributed, right? So we're saying there's 2 8s, which make, how much is 2 8s? Yep, and 2 negative 4s. Okay, and then over 2x y to the 4th. Okay, and so what do you do when you subtract powers of the same base? Or sorry, when you divide powers of the same base? So you subtract. Right. So 1 from 16 is 15, right? And then, now which one's smaller, negative 8 or 4? Negative 8, yeah. So I got to take negative 8 away from 4. So basically I'm saying 4 minus minus 8, which is what? 4 minus minus makes a plus, right? So it's 4 plus 8, which is 12. Okay, so the 2 is still here, and then the y is down below, right? Because this is the bigger number. The bigger number wins. So it stays where the bigger number is. Okay, so 12 goes down below. And you're done. That's it.
Those are fun.
Those are fun. I like it.
I always like
Alright? Now, this looks difficult. Question?
Yeah, so you multiply the 2?
This one? Yeah. When they're saying a power of a power, they're saying it's this times that, right? This times itself.
Okay.
So, right? So when you do, right? Then you would add those, right?
Yeah.
But isn't that the same as saying there's 2 of them?
Yeah.
Yeah.
Okay.
So that's what's happening. And that's why you multiply. More questions? Alright, how hard does this look? I'll make this easy. I'm going to make this easy. Okay? I'm going to use something I know to figure out what I don't know. Okay? Yeah.
So, number 12, do you always do it in that format?
Yes, you always do the inside first. And then the parentheses, if it's around the whole thing, you can combine them first. And then push it through. But if it's only on the top, you have to do the top first. And then you can do the bottom and the top. Does that make sense?
Yeah.
Good question. Alright, let me ask you a question. Alright, the log base 2. So 2 to the 3rd power is what? 2 to the 3rd power? 8. Right? So log base 2 of 8 is 3, right? We know that, right? Okay? Everyone understand that, right? Because the 2 to the 3rd power is 8. Does that make sense? Right? Alright. What if I said, if I said 8 to the 3rd, right? Or sorry, 2 to the 3rd. Sorry about that. I'm getting excited. 2 to the 3rd, right, is equal to 2 to the x. Right? What's x? 3. It's easy, right?
Yeah.
Okay? Alright. Alright. Well, slow your roll. Okay, so then what if I say that this, that 3, was equal to log base 2 of x? And what's x in this case? So 3 is equal to log base 2 of x, right? And it also log base 2 of 8.
So it's 8?
So it has to be 8, right?
Yeah.
Yeah. They're both equal to 3. Right? So that means that these two have to be equal. Right? So that just means that this has to equal this. That's all. Just like this has to equal this. that make sense?
Yeah.
Okay? Alright, cool. So, if the bases are the same, this is equal to this. Is that simple? Negative 3x plus 1 is equal to negative x minus 10. That's all. Is that easy? Right? And then it's just algebra. If these bases are the same, then these have to be equal. Okay? So in other words, if the log base b, right, of a, I don't even know, is equal to the log base b of c, right, then a equals c. Is basically how you would write that. Okay? All right. Complicated. Not complicated. Right? Keep it simple. This equals this, as long as these are the same. And then it's just algebra. Move your x. What's lower? Negative 3 or negative 1?
Negative 3.
Negative 3. So I add 3. And I get 1 is equal to 2x minus 10. Right? So 1 is equal to 2x minus 10. And then how do I solve for x? Add 10. Okay, so 11 equals 2x. Then what?
Then you divide 2 on both sides.
So then x is equal to 11 over 2, which is 5.5. Wait. Make sure those two answers are correct. X15, 2y12, yep. And then what's that number? 14?
14. Is it all good?
14.
What would that be under?
It says no solution for 14. I don't think so. There's a solution for 14.
So that would just be,
Did I copy on the wrong problem?
maybe that.
Oh, there's a solution for 14.
I try not to do that. That looks right.
Yeah.
Is that similar to what we did before? That was the rule? Yeah, I don't.
Oh,
What is
no,
wrong?
that should be fine.
Is the base clear the same?
Oh, wait. What's 5 times negative 3?
Where,
Okay,
where's
now this
that?
is correct. Now here's the trick. When I plug in 5, what do I get? 5 times negative 3, what's that going to be? Negative 15, right?
Yeah.
Yeah.
Plus 1. Is that still going to be negative? You can't take the logarithm of a negative number. So it's coming up and saying, hey, this is no solution. And the reason this is still right, x would be, if they said find x, well, x is 5.5. But is there a solution? Meaning you have to be able to plug it back in and go, is this number positive? Because if this number is not positive, you cannot take a log of a negative number. Right? Because think about that. If 2 to what power, right, is equal to 8? 2 to the 3, right? 2 to what power is negative 8? No. Negative 3 would be 1/8. And that's when we get into complex numbers. We start talking about 2i or 3i. Okay? But we're not in that yet. I'm not taking you that far yet. So, this is what we call no solution, because you can't get a negative number from this.
Oh, you can't have a negative exponent, huh?
Yeah.
That's when you.
Well, you can have a negative exponent, but it won't give you a negative number, right? Not when you start with a positive 2. Does that make sense? Now, if I started with a negative 2 and raised it to the third, I could get negative 8, right? But if I'm starting with 2 can't do 2 times 2 times 2 and get negative 8. I can only get 8. Does that make sense?
Yeah.
So that's what's happening. You can't take the logarithm of a negative number. That's why it says no solution. Okay? So when we plug this in, you go, okay, 3 times 5 is 15. Nah, that ain't gonna work. Just like 5 minus 10. That's still going to be negative, right? Negative 5 minus 10. That's still going to be negative, right? So you can't do it. Can't take a log of negative numbers. Does that make sense?
Yeah.
But getting this, you still do the same thing. You set these equal to each other. Alright? Now, are we running out of time?
You have 8 minutes.
8 minutes. We got time. Alright, so how are we going to do this guy? Alright, we didn't do this last period, so take it up a notch. Remember, logarithm, natural logarithm is base e. That's all. No big deal. When I'm adding things, right, I need to try to get the x to equal something, right? This one looks super fun. How are we going to do it? Okay. So I can't just, if I'm adding them, then I can be multiplying, right? Condense it. Okay? So ln of 7 times x minus 9.
Oh, that's an L?
Yeah.
Yeah.
Oh.
Equals 2. So what is 7? So everybody on the block gets the paper. So it's 7x minus 63. Is that right? Okay. So ln of 7x minus 6 equals 2. Right? Now, if I could get this to be an ln, then I could just set them equal to each other. Otherwise, I have to say e to some power, right? E to the 2 is equal to 7x minus 63. Because that's what basis is. ln of x is equal to the log base e of x, right? So, this is that whole e number. But I don't have to make it this hard. I don't have to use e. We can use it, but actually I can manipulate this too. Think about this. What is ln of e? ln of e is equal to 1, right? Right?
Yes.
Right? Why? Because the log base e of e, when the base is the same as the number, it's 1, right? Okay? So, watch this. This is fun. Watch. ln of e. 2 times 1. What's 2 times 1? 2. So I'm going to manipulate it. So this is log of 7x minus 63, right? Equals, and now put this on the top, ln of e squared, right? Okay? Oh, you still get the same thing. So now, this is equal to this. I get rid of the logarithms. So e squared is equal to 7x minus 63. Okay, so then I still have the same thing, I guess. So I make it easier. It's the same. Just a little bit more fun way of getting there. So I can either throw it into exponential form, or I can change this into a logarithm and then make them equal. Now I just solve for x. Plus 63 plus 63. So I get e squared plus 63 is equal to 7x. And then I divide by 7. Right? And you have a number e on your calculator. Okay? And so that e is right here. Okay, so I'll hit second e, and it says squared. So I hit, that's good, thank you. So I hit squared and then hit equals. So that's 7.38. plus 63 equals, so that's 70.38, divided by 7 equals, so that's 10.0555. So I would say that's 10.06. Right? So 555 changes this to a 6. Okay? And then I check and see if that's correct. First of all, is 10 minus 9 still going to be positive?
Yeah.
Yes, I can take the log of it. Okay? So then we looked it up real quick. What number was that?
19. I mean 29.
29?
19.
19?
No, it's 29, but do you remember Rosalie?
Is this the wrong test?
Is that? I thought you were going to
Which one was 29? Sure, it's the right test.
It's because Megan will say 19, she was like, say 19, Erica. 19.
No, this is a different test. Which test was I using?
That's the one that book.
Oh. Kind of neat. No, that's not it. I must have grabbed it from a different. This 29 is not that 29. Oh, this is actually 30 in mine. So let me check 30. I just wanted to see if I got the answer right. 30 e squared plus 63 over 7. Yeah. Okay. Just want to make sure. That's good. So this is actually number 30 on mine, but it's the same. Doesn't matter because they're all different numbers. Okay. So you're going to have different problems. This is just like 29 and 30.